GeopByte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. If the velocity of a particle is v equal to at plus bt square, where a and b are constants, then the distance traveled by it between 1 second and 2 second is velocity v given at plus bt square. From this I can say that velocity is depending on the time, where a and b are constants. Now you are asked to decide the distance traveled by the particle for the time period t1 equal to 1 second to t2 equal to 2 seconds. That is the question. Okay. As you know, this velocity v equal to dx by dt. From this I can write that dx equal to velocity into dt. Now dx equal to velocity equal to at plus bt square into dt. Now for getting the distance traveled, you integrate and apply the limits. Upon integration and apply the limits from 1 to 2, here it is integral 1 to 2 dx equal to integral 1 to 2 at plus bt square dt. Okay. Now it can be written as integral dx is x, apply the limits from 1 to 2, equal to a into t square by 2 plus b into t cube by 3. Apply the limits from 1 to 2. It is x2 minus x1 equal to a by 2 into t2 square minus t1 square plus b by 3 into t2 cube minus t1 cube. Okay, it is equal to a by 2 into t2 2 seconds 2 square minus 1 square plus b by 3 into 2 cube minus 1 cube. It is equal to a by 2 into 4. 4 minus 1, 3. Should be very careful. It is 4 minus 1, 3 plus b by 3 into 8 minus 1, 7. It is equal to 3 by 2 a plus 7 by 3b. That is the distance traveled by the particle for the time period from 1 second to 2 second. Look at the option C, 3 by 2a, 3 by 2a plus 7 by 3b. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. Two cars P and Q start from a point at the same time in a starting line, and their positions are represented by the position of the P in terms of time equal to at plus bt square, and position of the Q in terms of time is ft minus t square. At what time do cars have the same velocity? At what time, right? What is the time for maintaining the same velocity in both cars? For that, let us decide the velocity of the car P equal to rate of change of displacement of the car P dx by dt. It is equal to d by dt into at plus bt square. Simplify it. So velocity of the car P equal to, here it is a plus 2bt. Okay. Similarly, velocity of the car Q equal to dx by dxq by dt equal to d by dt ft minus t square, ft minus t square. velocity of q equal to f minus 2t, right? Is asking the time when Vp equal to Vt, Vq. If Vp equal to Vq, Vp is what? A plus 2Bt equal to f minus 2t. From this I can write that 2Bt minus 2t equal to f minus a. From this I can write that, let me write that t into 2 outside, t into 2 outside, it is b minus 1 is equal to f minus a. Therefore time t equal to f minus a by 2 into b minus 1. At that time the car p and car q are maintaining the same velocities, right? F minus a by 2 into 1 minute. Here it is, should be very careful. Here it is becoming plus, no? Yes, plus. This is plus, this is plus, this is plus. Because you are bringing this 2 to the other side, it is becoming plus. F minus a by b into 1 plus b. Look at the option D. Option D is absolutely correct. You should be very careful. Okay. Similarly, look at the another important problem asking like this. Two particles A and B move with constant velocities v1 and v2. At the initial moment, their position vectors are r1 and r2 respectively. The condition for particles A and B for their collision is, as you know, direction of relative position, direction of relative position of one with respect to equal to r1 minus r2 by r1 minus r2 modulus. Okay, this is the direction of relative position of one with respect to two. Similarly, velocity of or direction of velocity of two with respect to one equal to v2 minus v1 divided by modulus of v2 bar minus v1 bar. Dear friends, remember the condition for colliding the particle A and particle B is these two quantities must be identical. That means R1 bar minus R2 bar by modulus of R1 bar minus R2 bar must be equal to V2 bar minus V1 by modulus of V2 bar minus V1. Therefore, option D is absolutely correct. Understood? It is very simple question. Okay? Yes. Similarly, let us take the another important problem. Okay? Look at the screen. It is asking like this. A particle undergoes a one-dimensional motion such that its velocity varies according to v equal to bx power minus 2m. Velocity is given in terms of x. Velocity at a distance of x equal to beta x power minus 2n, where beta and n are constants and x is the position of the particle. The acceleration of the particle as a function of x is given by, you are asked to decide what is the acceleration in terms of x. Okay. For that, as you know, acceleration a equal to dv by dt. Okay. But as you know, velocity v equal to dx by dt. From this I can write that dt equal to dx by v. Therefore, acceleration a equal to dv by dt equal to dx by v can be written as v into dv by dx. Okay. That is the acceleration. Now acceleration A equal to V. V is beta into x power minus 2n into d by dx into V value beta into x power minus 2n. Simplify this part. It is equal to beta x power minus 2n into beta constant minus 2n into x power minus 2n minus 1. Here it is minus 2n beta into beta square into x power minus 2n that is equal to minus 4n minus 4n minus 1. That is the acceleration in terms of displacement. Look at the option B, minus 2n beta square x power minus 4n minus 1. Option B is absolutely correct. Understood clearly? Yes. This is also very important problem. This kind of problem can be repeated. That's why I am calling this is the 5-star problem. Okay. 5-star problem means most expected problem as a repeating problem. Okay.
GeopByte.